This is Mock Exam Review 2016-20, and we're going to work on question number 22. Question 2 is very similar to question 21 in that we're analyzing an AC circuit. However, we're calculating values of power. Now, there are three types of power that you have to memorize formulas for. There is apparent power, which we call S. There's real power, which we call R. And there is reactive power, which we call Q. And we say that S is equal to the real power plus J times the reactive power. Almost the same way that we write Z when we say Z is equal to R plus J times XC, or rather X total. So we will go through this problem and solve for these values and use the formulas that we know. Now, in order to calculate the apparent power, we need V and I, because the apparent power is the total voltage multiplied by the total current in the network. Just like in the previous power problem, in order to calculate I, we have to need Z, because I is equal to V divided by Z. So we need to calculate Z, and we'll use the same formulas as before. Square root of R squared plus XL minus XC squared. Now, in this problem, they saved us some steps. Number one, they gave us the value of XC directly. Number two, there's only one X in the problem, XC, which means we don't have to use XL. We will only be using XC in the formula. So the value of Z, after you put those numbers into the formula, would be 25 ohms squared plus a negative 50 squared. And you know the negative will just cancel. So after putting that in our calculator, I calculated approximately 56 ohms for Z. Of course, we also have an angle, because we might need that angle for some of our calculations. So remember, the angle is the tangent inverse of the reactance. In this case, it'll be minus 50, divided by the resistance of the circuit. In this case, is 25. I calculated a minus 63.4 degrees. Okay. Now we have the ability to calculate the total current in the network, which from before is V total divided by I total. In this case, it's given us the V total as 220 volts, and we always assume that the power supply is 0 for most places, because it is our reference voltage, and we'll divide that by this 56 ohms and its phase shift. All right, from the math, we'll take the 220 divided by the 56 to give us the magnitude, and then we'll take the 0 minus the negative 63 to give us the phase shift. So I got 3.93 amps. And of course, 0 minus a negative will give you a positive value for the phase shift. I'll drop the 4. Okay, so that's the current. Okay. Now we're actually prepared to calculate the apparent power for the circuit. The apparent power for the circuit which official label is called S, is equal to V multiplied by I. When we're calculating the apparent power, we're only going to use the magnitude values. So we're not going to worry about the phase shift unless we're going to draw the power triangle. after we take 220 and we multiply it by 3.93, we get 864. But be careful. The unit for apparent power is volt amps. It's not watts. Now the real power comes from the current interacting with the value of the resistor, because we have a loss of power through this resistor. Well, we have calculated the current in the problem already, and we have the value of the resistor, so we can use the very popular power formula, I squared multiplied by R. There are other formulas that you can use for this same problem. So that'll be 3.93 squared multiplied by 25 ohms. That gives us 386, and the unit for real power is watts. Now, in case on the exam they ask for the reactive power, you can always calculate the reactive power by using the same formula, I squared, but this time instead of multiplying by R, you multiply by the total reactance in the circuit. In this example, it will be XC, which has a value of 50 ohms. So since that is 2 times the value of the resistor, then you can expect this number to be 2 times the result. Thank you.